I'm going to be pulling this thing apart, checking it out, recapping it. It's the model 4200 RF microwattmeter by Boonton, as you can see. So it needs a bit of care, a bit of TLC, so we'll pull it apart and have a look, take it around. Because this had some odd behaviour when I first got it, that's why I'm recapping this one. And because of the age, I mean they're pretty old units now, so I just want to do it really as a preventative measure. And there's not many capacitors in there, and they're not, I don't think they're serving any particular important function apart from power supply stuff, so there's no real harm in doing it. It's probably only a good thing. Generally, when it gets to a certain age, it's a good idea to recap. You know, it's just a good idea to. My experience anyways, it's best to do it. Oh, sorry, I've already taken that screw out. I've taken this top screw out already because I started before I realised I should start recording. I need to take the other screw out, which I need to get a screwdriver for because I haven't got prepared. Okay, got a screwdriver. Let's get this screw out. So there's only 2 screws to get this panels off, which is quite nice. Okay, 1 panel. So here, that's a Gpib card basically. And it's got these antenna connects on the board edges up here, which you can't see because I'm not in shot, because I'm a dummy. Right. There you go, there you can see it. Right, so board edge connector over here. So it's got fingers on the edge of the card. So it's got under the screws and you slide the card out, because these are on like flexes as well, I think. So the whole thing can move around a little bit. I did actually have this board out once already, but see there's a couple of capacitors on here. Not much. There's a tantalum, but it looks fine. It doesn't look discarded, so I'm going to leave that alone. The bottom board will also come out. So look, now this one here, it did come with a missing foot. This foot here was missing. You can probably see it's actually dented around there as well. Is it? Oh, that's right, it's raised section, but it was dented here as well. It was dented, it had been dropped or something. Maybe it's this one. So I've straightened that out already and put these new feet on. These are 3D printed feet. I made these myself. I just got the original profile, the original one, and made some more. These are actually slightly higher. Right, so not the original feet. The original feet are actually slightly lower. I think it's because I measured it wrong. I had the diameter, which is 20mm I think, and I made these the same height. Well, it should be less than that, I think 5mm less. Do you know what? I didn't care. What else I mean, when it's sit on a shelf, it will face downwards slightly. So if it's above you, actually be facing towards you, which would be, you know, might do you a favour, I don't know. Anyway, so 3D printed feet, these are on my Thingiverse page, if you need these feet. They're just generic. It's just a post with a bolt hole mount in the middle of it. So you can bolt straight through it. You can use them with anything. Not necessarily on this, so if you need these, go and check it out. And that's what's on the other side, see, just bolts. Because I had 1 foot missing off that unit, and actually I'll show you something. And this is the other unit I've got, which is the 4220. This had a foot missing as well. So what I did, and it has the same feet, exactly the same feet. So I took the one remaining foot off this, put it on this one to restore this one to the original. So this is the original feet on this one. You see the slightly lower profile, maybe you can see it. And then I put the 3D print on this one, obviously. So let's bottom cover off this thing, and there's the main power supply just here. What year is this thing made? 91 I think. It's got an SP9112 at the top of that device. So that says 1991 to me. So yeah, I guess it's 1991, at least that chip there is, so it's probably going to be around that time. Look on this side, what chips? What does this say? So what we got here? Don't know. 80? 1980? Metal chip's been replaced. No, nothing in there. This is 82. This is 83. So this Gpib board is 1983. So that's probably when it was made. So I'm guessing then that either this code, which I think is a date code on the power supply over here, isn't a date code, or a chip's been replaced at some point. My guess sometime after 1991. But I could be wrong. So we've got a few things to do here. We've got to get this board here out, this cover. You see there's actually an optional board that can go in here. I think it mounts on here maybe, I'm not sure. These are like standoffs. Now I did actually find that this standoff here is broken. You see I've already mounted it because I've already taken this off once. The standoff there was broken off the main board there where the threaded section goes in. So that's why I said don't remove that bolt, because the whole thing's going to fall out anyway. So we've got this card here we've got to take out. We've got to take this board, this cover off, and there's a board under there which has got some caps on it. And then we've got to take this Gpib board out and replace those couple of caps on there, and the board underneath that I think has got some capacitors on it too. So we've got a fair bit to do on this unit. So I think I might start with the top side here, get this out of the way, because I think this was the simpler side to do, then we can forget this side and be done. Right. Flat blade screwdriver. Screws. So the things I like about this kind of age equipment is it's well constructed, it's well made, it's made for serviceability. You know, you can get in there, you can pull things apart, and it's usually designed in a way it means you can actually pull it apart and do work on it and not have to have too much effort to do that. Some gear obviously that's not the case, but generally it's been right. I mean, look inside this Boonton gear, it's quite impressive. The other unit, the 4220, that's a really nice inside, that's beautiful. It's a really nice construction. Really nice indeed. This isn't bad. It's also quite impressive. But old technology, you know. Over 30 years old. Okay, so the screws out. This should now want to move around a little bit. Unless I'm missing something else. So I've got this header off, so that will move backwards and forwards. Let's slide this off. So I'll kind of slide it back and then forwards again. Is that it, or is it afterwards? I can't remember. I really don't remember. Okay, I did get this card out once before. How did I do that? I'm pretty sure I popped this off first. Yeah, I did. There we go. Then this should slide out backwards. There's a connector here as well, got to take off, which has a blocked up pin so you can't get it wrong. 5-pin header with only 4 pins on it, with 1 pin missing, and this has got a plug in there so you can't get that back to front. Nice detail, isn't it? You know, that kind of thing. So this has got 2 capacitors on here I need to replace. Pull this out of the way for now. And that's what the inside looks like. So it's only a couple of capacitors on this side as well. There's like 2 there, 1 more down here. And I think there might be a couple of bits underneath the shield here, I have to look. Yeah, there's a couple more caps under there, I think. I think there are. I have to have a bit of a look under this. Yes, removal of components in this section can lead to instrument malfunction. Yeah, so I have to worry about this piece. With a warning sticker in there. So if there are caps in there, there's a little hesitant about whether or not to change them. Maybe I won't. If it may upset the instrument. These other ones are just power supply stuff, so it's not particularly important. So to get this board out, it's very similar to the other one, where we've just got these headers, these standoffs we have to take out. And there's a few plugs here as well, also keyed, the same method, with the pins, which are blocked off. You can see that there. And also a multi-way header here. Little dip type socket. And again, you got this edge connector ribbon cable here. So also very nice. So again, we can just take those out, take a couple of connectors off, and the whole board can come out. So it looks pretty easy. So we'll do the top board first. We'll get that one done. And then we'll pull this board out and do this one, and we'll reassemble this side. And then we'll swap sides and do the other side. Okay, so here's the Gpib card. We've only got 2 capacitors replaced on here, so it's going to be pretty easy. It's interesting construction. I mean, it's old. I think it's phenolic boards, aren't they? I think they're phenolic. You have to be really careful with these. You don't want to put hot air on these because these will delaminate. Just a bit of a warning for you. Don't learn from my mistakes. All the soldering is beautiful on this thing. It's all really nice. Yep, someone took a lot of care over this thing when they built it. Anyway, let's replace these 2 caps. So what do we need? 25 volt, 10 microfarad. And 25 volt, 10 microfarad. And I just happen to have some, which have just arrived today. So we've got the parts we need. Alright, so there's the capacitors are out. These are ZLG series, in case you care. I really don't. I don't know. It's just power supply caps. It's not too critical a function. So the original caps are here, 85-degree caps. The new ones are 105-degree. I always do an upgrade if I can. I always buy 105-degree caps. You pay a bit more for them, but then you know you got a longer lifetime generally. If I'm replacing something, I'm going to replace it to last a long time. I'm not going to chuck in rubbish or inferior quality in this. I really have to, you know, sometimes you've got no choice because you just can't get the other parts. Anyway, so I need to get these capacitors out. So negative, this one's facing towards this hole. Mustn't forget the polarity because there are no markings. Yes, there are no capacitor markings. Actually, I should get my desoldering gun running, shouldn't I? It might be easier. We'll get that fired up. Okay, I've got this thing going. It should be up to temperature by now. It's going to be a little bit noisy though, that's the only problem. So, let's get this capacitor out. Yeah, it's not soldering very well. Yeah, it's not working. Might have to use it to clear the holes out afterwards. Let's just resolder these and do it the old way. We'll wiggle it out. Could have spent these first shoulder to get going. Or it's still coming up to temperature. Right, let's wiggle it out. Hope you're watching which way the negatives was. Okay, that's that one out. Let's clean these holes out. As it's double-sided board, I can do it from this side. Yeah, it looks like it's worked. Okay, negative towards me. As you compare the size of these caps, here's a bit of different size. Yeah. What brand are these things anyway? The originals. Kangjan. Is that? No, Kardjan. K-A-H-G-A-N. Never heard of them. Don't know. There it is. Oh, zoom in on this. See that? Never heard of those. New brand on me. Right, get the other one out. Do the same technique, wiggle it out, then suck the solder out after. Should really get my bloody extractor going, but there's not much smoke coming off this. Okay, that's out. Cool. Holes cleared out. So yeah, there's going to be a bit of this, just like placing caps. There's not that many to do on this thing, thankfully. Solder new ones in. This is SN62 solder, which is a tin lead silver base solder. So it's actually a triple alloy, and the silver helps to give a nicer joint. So higher quality, it costs a bit more, but sometimes you want to use the best anyway, and that's fine. Like in this situation, I want to use better quality. I think it's sort of 50% more than standard solder, something like that. It's a significant increase. Right, keep it clean. There should be like a flux residue here and here as well. Looks a bit like flux. Might be something else. Just a weird splodge just there and just there. It's a bit strange. Who knows? Maybe some kind of spill or something from some other work that's done. Who knows? It's coming off anyway. Partly coming off. We'll call that all done. Let's go and pull the other one out. Actually, I thought I'd better measure these capacitors before I move on, just out of curiosity, see what they actually like. I always do testing at 100 Hz. I always do. I don't know. Maybe someone's got an opinion about whether that's the best frequency to use, I don't know. But anyway, this is what we get. 9.6 microfarads, so they're looking okay actually. Dissipation 0.1, doesn't look too bad. ESR 23 ohms, yeah, it's getting up there. Probably not too far off what it should be though. Check the next one. 9.8 microfarad, 26 ohms. This one's slightly higher, so they probably are aged a little bit. I mean, I think probably this value, I mean, there's only 25 volt, pretty small caps. You might expect, you know, maybe 10 ohms or so, 12 ohms maybe. So they're definitely pretty high anyway. So I think they were on the way out. It seems a bit too excessive. Dissipation didn't look too bad though, so yeah, you're cool. Okay, well, let's get this board out. And I probably should look at a tool to get those out. Does this fit? I think these fit, don't they? Yeah, these fit. See, standard hex on screwdrivers fit these standoffs. In case you didn't know that, you probably didn't know that. So inside here, it looks like, I don't know, from what I can see at the end, it's like a pair of capacitors in there, but it's a Zoda on standoffs, like little posts that mount onto the actual capacitors. That's what it looks like. I could be wrong. I can't really see. I might take the cover off and have a look underneath it. But if it's that kind of situation where it's on posts and everything to make sure it's all controlled, then it's the sort of thing I probably don't want to be changing unless I actually have a reason to change it. A lot of times we just change caps because, you know, it's old. Sometimes you change caps because you have to, rather than you want to. Sometimes it's best to leave things alone. You have to sort of judge each situation as it comes along, really. So in this case, I think it's a case of likely leaving this part of the circuit alone. Unless do the power supply capacitors and just leave it at that. We'll see. I'll have a look in there. Maybe some information in the manual about it too, but I haven't read the manual, so who knows? Maybe it does, maybe it doesn't. So these here, slide these off. So 2 plugs, both of those pins missing there, and a different size as well, so you can't get those mixed up. And you've got a dip plug over here, so unplug this. So that board should now come out. With a bit of luck. It certainly wants to move. I think I might try and lift it sideways if I can get it past this cable retainer. Maybe. There we go. So what's under there? See, it does look a bit like capacitors, doesn't it? No, they're not capacitors, they're something else. That's interesting. What on earth are they? See, from the end it looks a bit like capacitors. That's what I could see as that. But they're definitely not, there's something else. Very curious. They look almost like batteries, don't they? Tantalum hiding under there too. Looks okay, it's not discoloured. Couple of chips. So yeah, we've got no reason to pull that cover off. Okay, so that's that board there. We've only got 3 capacitors changing this board. I mean, it's barely worth taking the thing out, to be honest. But, you know, it is. So these are 25 volt 10 microfarad as well. Yep, all 3 of them are the same. Oh, there's one more over here. I must miss that one. What's that one? Probably the same too. We've got their bombs set up right, they'll be the same. Yes, they are. So there's 4 capacitors changing on this board, which is fine. This is with these joints with new solder. It does help them to come out. This one's been folded over, that's going to be a pain. So there's a part being removed here. Just here, it's like a jumper's been moved. What the story is with that? You can see it was solder that's been removed. That's curious. Because one side's going positive, one side's going the negative row. Because it goes to that centre pin there. Very interesting. It's on an EEPROM, so it's changing a program pin on an EEPROM. Interesting. Maybe they changed the EEPROM, did an upgrade or something. Or removed an option. Maybe it had an option in the unit and they removed the option. because there is like a board which can be in there which has been removed, or is not included at least. So negative towards me. I should reckon like that. Negative towards me. Negative to the left. Really? That must be a negative. Nah, it can't be a negative. Oh, yeah, there it is. That's right. Look, the bottom trace isn't a negative trace. It must be a positive trace. Yeah, top one's a negative trace. This one's a positive trace. Must be. It's going to the other side. I'm going to forget these capacitor layers, aren't I? I know I should probably just put the new ones in straight away. Let's do that. We'll put the new ones in straight away. I was going to forget. I'll lose track. Okay, negative to the left, negative towards me, negative to the left, sometimes that wiggle technique is just the easiest way of doing it. Instead of struggling with it, sometimes, you know, this vacuum pump thing, it works okay, but it's not 100%. It's not wonderful all the time. So I think part of it is because the tip I've got on there has got too big a hole in it. Negative to the left, right. No, left, not right. Out. Certainly is a nice easy way of cleaning the holes out. Right, get solder on. So these RF watt meters, they're for measuring RF power. So if you're trying to line a transmitter or something like that, or trying to work on an instrument which has an RF output of some kind, you can measure the actual power output. Within reason, you've got a limited input range, but it depends on what probe you've got attached to it. Usually you have to use a dummy load or an attenuator of some kind in order to drop the levels down if you've got a transmitter. But other things you might be able to use it for testing, like levels inside an instrument as well. Like you've got a RF section inside an instrument, which is an interconnect, like an RF section or something like that. You can measure the RF level, make sure things are in spec. All kinds of different uses, but I have never really used one myself, even though I've got two of them now. But that's why I bought one, because I didn't have one. And I couldn't decide which one I should use, so I bought two. Yeah, I don't know what. So I'm not actually, I mean, apart from the original fault where I saw some weird behaviour on the display from this thing not seemingly working correctly, I'm not aware of any problems with this thing. So I'm hoping it's just a case of recapping it will maybe sort some power supply problems out. I mean, I don't know. I shouldn't actually measure the power supply, shouldn't I? Haven't measured them at all. I'll just tell them, right, it's got bad caps and let's pull it apart. So, yeah, anyway, that's that all done. So we can reassemble that side of the unit now, after I've tested these capacitors, because I'm sure you're all curious to know what these come out like. I wish it would default to the thing I used last. That'd be really nice. series. I always use 100 Hz. I don't know. Is it the right one? Maybe. It's on there. So 9.3.2. This has got a higher dissipation. So the ESR might be higher on this as well. ESR 44 ohms. Yet that's definitely worse than the others. ESR is 18 ohms on this one. Looking slightly better. 0.1 dissipation. Dissipation again, it's got a slightly higher capacitance. ESR 17, so yeah, 17 is getting close to where I think there should be, but I think it's still not quite right. It's 14, there you go, it's getting close to where I think it should be. This one's probably alright, to be honest. Dissipation 0.09, so yeah, I think this cap's probably alright, the rest have been failing. So, as suspected, worth replacing them. Now, even though there's no obvious reason to do it. Okay, let's put this back together. Now these these are aluminium, or aluminum if you want to pronounce it that way. Depends on your level of yankiness. Now the thing with these, you don't want to over tighten them. Now as I say, on the other side of the unit I found there's one that's already been snapped by someone, which is a shame. I should actually, oh no, these are bloody imperial. These are imperial as well. They're not metric, these are imperial. Because I was going to look at replacing the one I found that was broken, but as I say, it's not metric, it's imperial, and I've only got metric ones. And it's usually when you get the last one screwed down, tightened up, it's when you find out you missed something. We'll see how that goes today. That's usually the way it works. This is a bit tricky, but we'll try and get a finger in there at the same time. There we go. Again, this week we could need Chris here. Chris is, you know, great use in your windows. Right. Again, just enough to be secure, not too much. Don't want to snap these. I've got nothing to replace them with. Right, yeah, nothing broke. At least not yet. There's still time. And for those of you who don't know what I'm talking about when I say, when I'm referring to Chris, I'm talking about All the Gear, No Idea. He does some interesting videos as well. If you haven't checked his channel out, go and have a look. It's quite entertaining. Quite enjoy watching his stuff. Okay, so that ball back in. Next ball. Then it has to go underneath the ball and come through that slot like that. It says meters can be used quite well for all sorts of functions. Anything you need to measure losses or levels. So you're limited by imagination really. I mean, you can use them for measuring cable losses and stuff like that. But you have to bear in mind, bloody multimeter turning off, you have to bear in mind if you're measuring losses that you're measuring at the frequency that the instrument tests at, which is generally 50 megahertz. So if you're trying to figure out what losses are, that's great, but it will tell you at 50 megahertz, not at 200 megahertz or whatever you may be trying to figure out the loss for. So that's something you have to bear in mind if you're using this for loss calculations, is you have to extrapolate what your actual loss will be at a different frequency. And generally the best thing to do is just look at the specs for the cable and find out what that states anyway. If you know what the cable is, of course, sometimes you don't know. But it'll give you an idea anyway, it'll give you a ballpark loss figure. One day I'd actually tried using GPIB. I've never used it. I've got a adapter, USB to GPIB adapter. I just really need to get around to actually giving it a go one day. I think mainly I want to use my CMU 200 because that's got some restrictions about how you can do testing on that. Okay, so that's the top part done. Oh, no, not quite. Plug the plug in. Last plug. Always check the plugs. Okay, now that's that side done. So we'll put the cover back on that side. I'll show you power it up first, see if we get any smoke coming out, in case I've screwed something up. Yeah, that's always a good idea. This plug powering. Check for smoke, the old smoke test. Well, that's almost disappointing, really. It didn't go bang. So obviously when you're using these meters for measuring losses and stuff like that, you use the cal factors that are mentioned on the probes, because you get probes with them and they've got calibration factors included on the probes, actually on the probes themselves, to tell you what they are they're rated for. So the idea there is that you factor that into the calculations. So you've got the calibration at 50 megahertz, for example, and then you might derate it or add a bit on. It'll tell you what a factor is. Right, this will come out. That's just the cover, and this is a bit more interesting, this one. So there's a few caps under here, and it looks like it's going to be a pretty easy ball to get out. It's got this interesting connection just here. Go out to this little box. We're not going to be touching that. So, so yes, this one looks like it's pretty easy to get out as well. So the post here is, say, it's broken off. You can see that there. The stud's gone, which is why it says don't remove. Well, I put that on there because I found it was broken. And I've actually removed the stud that was broken off in it as well. I've taken that out in case it falls out and floats around inside the unit or something like that, because you don't want that to happen. Yeah, so it's a shame, but aluminium standoffs. 3 standoffs take off. There's no extra screws, just those standoffs. And this wire probably have to stay attached, I'm guessing. So you have to be careful about that. I might have to do a thing, just lift it up inside the unit and work on it inside. And also got to take this plug here off and that plug there. And we've also got the power supply, which is going to be the harder bit to get out. Let's have a look at that. So I've got a couple of screws here I've got to take out. Which, was it those two? No, there's 2 here, the top 2. Or the bottom 2, because we're working in the bottom unit. Those 2 screws here have to come out in order to remove the heatsink section from those transistors there. So that whole assembly will come out then. We'll take those, and these screws here. I don't know if there's anything underneath this cover. Might take that cover off as well. There's also a protection for the power socket. You've got the AIM AC coming in there, so it's a bit of a anti-touch protection. And then yeah, so that's the power supply section. We have to make sure we do these carefully, because these are all different plugs. So we have to make sure we don't mess this one up. Who knows what could happen? Who knows, it might be exactly the same rails on each plug, maybe that they're all identical, I don't know, but it's got the marking here, it says 4109875. See that just down there? No, that might be okay. Look, there's someone thought about what they're doing. There's 4 on that cable, 10 on that cable, 9 on that one, 8 is not present, interesting, and we've got 7, I'm guessing, must be 7, yep, 7 and 5, so that's all fine. So in fact there's a plug number 8 which is missing, and this extra connector here, I believe there's an option board for this. It may be to do with these extra inputs, because you've got these channel 1, channel 2 on the back here, which are not populated. The channel on the front is channel 3. So I believe because that's not installed, you know, obviously that's that whole separate card. So obviously that's an option which I don't have. That's fine though. We'll do this one first. Mind you, it's got a whole bunch of caps on here. There's 8, 9, 10 caps we've got to do on this one. It's quite a few. And being an awkward one, so I can't take it right out of the unit, it's also going to make it interesting. But yeah. Pull that off there. Again, it's a keyed plug. It's got a plug in there. Plug in the plug. So, nice. How many caps we've got on this one? We've got 4, 7, 8 caps on this one to do as well. Hopefully get this out. That's off there. Get these standoffs out. Where's my screwdriver gone? Here it is. Then we'll see about, oh, that's a bit of an angle, I have to watch out for that, I don't want to put stress on it. Then we'll see about what we do with this cable here for this last piece. I'd like to get the whole board, well, the board right out, but there's no, I don't know. I thought that the cable would plug in somewhere. Let's have to unplug it from the front panel, I don't want to go there. Always watch out for washers. Always. a lot of gear, especially this older stuff, has locking washers or some kind of spring wash or something in there, or even just plain washers. A lot of gear has it, so it pays to be really careful about watching out for that. Now, what we'll do about this cable? Is it a plug? No, it's soldered straight on. Okay, soldered straight on. Better make a note of these wires. Black is to the left, red is to the right. Okay, got that? Right. I'm going to have to do this thing in place. So I've got a solution to the whole ball wire thing. I was tempted to take the wires off, decided not to do that because it's a little bit awkward. So I thought I'll get my little panel vise here and just clamp the board up, because there's a flat piece of board here with nothing on it. Plain board, no components. So I clamped it on the vise here, just standing here. And that way it's not stressing the wire, we're moving the thing backwards and forwards, flipping it over all the time, which will break the wires most likely. Because they're old wires, they're going to break. And that way, if I want to work on each side, I can just spin it around and just tip the whole thing around instead of tipping the board around just to use the whole unit. That way it's not stressing it. So now these caps, what we got here, we've got 25 volt, 10 microfarad, just like a whole bunch more of those, loads of those, yeah, 25, 10 microfarad, they're all going to be the same, aren't they? They're all going to be the same. Can't see what those are. They all look the same. Yeah, 25 volt, 25 volt, 25 volt. Yeah, all the same caps. So we've got 8 caps there, which is exactly the same. One more over there, which is probably the same as well. Question is, do I buy enough? Yeah, barely. I do have some other ones. I've got some 35 volt caps as well. So what I need to do is I'll probably take out the ones which have got the negative facing upwards first. Take those 3 out in one go. And then I'll probably change orientation, switch orientation to each one. That way I know which way they're supposed to face. The only problem with soldering vertically, it makes it harder to get the solder to stick because it wants to run off the board instead of running through the board. One. Again, I'll test those capacitors when I finish doing the board. I'll test these caps and see what they actually get, see how many have failed. These actually have a positive marking on the board. The other boards didn't have that. It's nice. Wish I'd done it on the other boards. So I probably could take all these caps out in one go, since it actually has a marking. These soldering guns, they're a really good investment. I highly recommend you get one if you don't already have one. Doesn't have to be a good one, this one is a cheap one. Follow my links down below in the description, just to Banggood. They're probably on there, if not you can get them on AliExpress. I may remember to put a link down below, going straight to one of them on the listing or something. So if there's any way I'm going to mess up getting the polarity right, it's going to be this board, or but maybe the power supply. You know, one of these big caps. Maybe I'll get one of those back and put it back in front. That'll make lots of smoke. If we're going to mess up one, it's going to be something. Okay, normal here, which is a 100 microfarad 25 volt. The voltage is a bit different to what I'd like. I mean, I like to keep it within a region. 50 volts is quite a big jump. I prefer to go into like a 35. I mean, shall I have another look, see if we've got one. So we've got something else which is smaller voltage, which isn't a crap around. There's a 35 volt there. What's that one? Suntan. No, not putting that in. Got a whole bunch of those bloody things. Must have been desperate for them. Yeah, I've only got this one. This will do. This will have to do. Right, so let's get these parts soldered in. Could try and get it through the board as well. The amount of times I watched a video back when I've been editing it and go, oh, that wasn't very much in focus, that was a bit blurry. Or stuff like that. Or, wait, I'm a long way away from the camera, but I can't see anything. That happens a lot. So I'm always trying to improve the editing and the framing of my videos, try and make it easier to see what I'm doing, but sometimes when I'm wrapped up in what I'm doing, I kind of forget to check. Or I look at the camera and think, oh, I look at the screen and think, oh no, you can see enough from that. And in editing, I'll go back and look at it and find out that, oh, actually, no, you can't see a damn thing. So I try and avoid that if I can. Didn't used to care about it too much when I first started doing YouTube videos. It was more about the diagnostics and the repair itself rather than the detail of watching me do the thing. You know, it's all about that stuff, and now it's a bit different. I try and do a higher quality if I can. Once this board almost done, all I've got to do is give it a clean. We can put this one back in and do a smoke test, see if it goes bang. Always hold on to these things when you cut them off. Don't let them go pinging off, because it could go somewhere you don't want it to go, like into the chassis, and you don't notice this. And if it goes into the chassis and you don't notice, you can end up with killing your instrument later on. Next time you turn it over, next time, you know, just turn it that way and the thing falls onto the back of the circuit board and shorts all the stuff out, and you never know quite which bit was blew up, because you never know where the short was, because it'd move. You wouldn't have nowhere to start. Tip this over some more, might be a bit easier to clean it. Just done it that way, shouldn't I? I was doing the soldering. You get the idea, I won't record the rest of this. Okay, let's put this board back in again. It's all cleaned up. Managed to not break those wires off, which is nice. Just try to slide the connector. Right, get those standoffs back in there. This is when you drop a screw down somewhere. Something awkward, you can't get to it. Oh, almost. So nearly done. It's got the power supply to do. Connector, make sure it's not tucked underneath. And let's plug it in too. Again, don't leave that too tight, just like necked up, just so it don't come loose. This is a smoke test. I don't have to plug anything else back in again, just do that. Although all the indicators are on. I'm not sure it's fine. Was it like that before when I did the first test? Now I'm worried about something else breaking. Having all the indicators on. If I made something worse, it's possible. I'm pretty sure I plugged everything back in the other side. We'll do the power supply and get that bit out of the way, then I'll worry about why it doesn't work anymore. Oh, yeah, well. Right, let's test these caps, see what we actually pulled out, see what condition they're in. So 105 microfarad looks alright, dissipation looks pretty good, this one was probably alright. ESR, 1.3 ohms, yeah, it's probably right. Don't think there's really going to be a problem with that one. Next, 10 microfarad, 15 ohms, yeah, okay. That's one of the better ones. 10 microfarad, 15 ohms again. So we have found some which were bad. Well, certainly different value. 10, 16 ohms, yep. 17, 10 UF, yep. 15, 10 UF. Microfarad rather. Keep saying UF. Old habits die hard. 20 ohms at 9 microfarad, or 26 ohms at 9 microfarad. So yep, that one's going bad. 20 ohms at 10 microfarad, yep, that's also going bad. You know, 12 ohms at 10 microfarad, that's one of the better ones, that's probably the best one so far. And 13 ohms at 10 microfarad, so yep, okay, so we found most of them are, you know, okay, a couple are definitely failing, and there's a couple of good ones. Well, probably good ones, good for the age at least. Oh, let's check this one I pulled out as well, which I kind of cocked up. So this one I'm putting in 5.4 ohms. This is what the brand new one's measuring at. 9.5 microfarad. There's a tolerance, you know, it's like 10% tolerance, something like that, so it could be, the other ones I'll put in could be 10. That's fine. Right, so now I've got to get the power supply up. I've got to take this panel here off so I can get lifted up. So I've got a couple of screws I've got to take out the back. Looks like I've only got probably 3 screws there, but there might be another one over here underneath this shield here. We'll see how we go. But, there's just a couple of cables here. Now, these are all marked, and this one I can't get wrong because it's AC and it's probably polarised anyway. So let's get the screws out the back first. That's nice and tight, so it's probably never been off. That's a good sign. So we've got a shield over there, and it's also got insulation on these terminals too. So that's a nice touch. They really looked after the safety side of things. But the voltage switch doesn't have much in the way. It's got some on there, but not all of them, not all the terminals are insulated. There's another screw under there which I can hopefully get to. Let's take these out. We should release the heatsink. It probably has thermal compound there which will need replacing anyway. Right, let's try and get in here. This is going to be a little bit tricky, I think. No, that's enough. That's alright. So let's take these plugs out before I go any further. I was having trouble holding the board down at the same time. Let's power it in, and let's say these are all labelled, so I should be able to pull these out and put them back in the same places. So cool. There is some adjustments on here, so I might even look into those and check the power supply calibrations. I have to look at the manual for that actually, so I can find that. I have to say, Boonton are good at designing stuff. So I've got one more wire here which I have to get off. Now this red wire is going to this post here near the end of the connector block. So I have to wonder why they've got that extra wiring in there for. It's interesting, I wonder why they have that. So, don't forget, post closest to the connectors here, towards the end. Right there. Which is going to like pin, well, I'm guessing that's pin 1 on this end. Is that right? No? Yeah, pin 1. Pin 1 of the in connector it goes to, basically. Right, now did I get all the parts for this one? What do we need? 2200 microfarad. Or 3300. That might be for the other unit. There's a 4700 as well. What has arrived? What are these? 4700? Yep, I need one of those. So, check, we got one. 1000 microfarad 10 volt. 1000 microvolt, can't say, 1000 microfarad 16 volt, so I'm upgrading the voltage slightly in this one. It's also somewhat smaller. If you get closer, I'm too zooming out too far. Here you go. This makes more sense, doesn't it? Here you go. You get to see. I'll even focus it for you, how's that? Bloody hell. Right. So yeah, 4700, which is significantly smaller. Well, not significant, but smaller. And the other one there as well, significantly smaller. That's half the size basically. And this is a, what's this, Rubicon ZL series, and this is a Panasonic, is it NHG series, is it? Might be NHG, I don't know. I don't look at the specs of the capacitors like, well, I want the right voltage. All I really care about is low ESR in switch mode supplies. Then I'll make sure I buy low ESR caps. This is just the linear power supply. Any old crap will do, basically. Really, to be honest, just make sure it's, you know, high temperature rated. These are 105° rated caps. Alright. Yes. Right. So that's those ones. You've got these, the other 3 caps here, which are 16 volt, 100 microfarad. All 3 of them are the same. I hope they're not the ones I'm waiting for. Oh, that's right. Where are they? Don't have some here just now. Yeah. I should have had some more caps here. I lost them already. Oh, anyway, I'll sort it out. Okay, so we got those 2. I need to get those 100 microfarads, which I have some here of, but they're not good quality brands. These are some 10, which I don't trust. They're okay for consumer electronics, but not for test gear. I wouldn't put poor quality in test gear. There's a Rubicon, 50 volt. This might be what I was using before. So, yeah, I might have put Rubicons in there. Yeah, it's a bit of an overkill in a way, with the voltage wise, but these are VXF series in case you care. What are these ones? Oh, there we go. 25 volt, 100 microfarad, 20 Rubicon. Okay. So that's the 2200 we've got to look for now. What did I say they were? 35 volt. 25 volt. Uh-oh. Here's the 35 volt. And here's the 35 volt. Here we go. Be covered. Right, I've got the caps ready. I wasn't sure all the capacitors had arrived, and I haven't, because I did buy some more of these as well. They haven't arrived. So that's fine. I've got the parts I need, so let's make sure. For 7 caps. For 7 caps. Yep, I've got the parts. So let's do this. Alright, so here's the board. Surprised there's no thermal compound on here. I'm actually really surprised by that. I was expecting there to be you know, a method of getting heatsink, the heating away from the transistors, but I guess they figured there was enough. I don't know. Unless there's a thermal pad stuck to the casing. Let me have a look. no thermal pad. So, yep, it's just going straight to the aluminium body. I guess they figured that'd be enough. So I'll probably put something on there just to help it, a bit of thermal compound just to help keep the temperature down. You don't want things getting too hot. I don't know, these things may not be generating much heat anyway. I don't know. Right, let's get started. So, are there markings for the polarities? No. Don't get this one wrong. This will go lots of smoke if I get this back to front. And in fact I think I will get my air filter running now, and I'm actually in a position where I can use it. Is that one? So negative is downwards. Yeah, negative was downwards, wasn't it? That's right, yes. I hope I got that right. Who has short-term memory loss? It wasn't me. I remember that. Other solder. Next one's that one there. Negative towards me. I could probably actually upgrade these to bigger size, really, couldn't I? I'm not going to, but could have done. So what's this one here? That was the 1000 microfarad 10 volt, which is that one there. Negative downwards, well, to the right in my case, or downwards if I've got this down its end. And probably what I should have done on this is scoped the power supply, check the ripple and that sort of stuff, and just verify that actually, well, see if there's any problems in there originally or not. I suspect there were, but I should have probably done that, and so I could do like a before and after comparison. That's probably what I should have done. UA78GU1C, there's two of those. UA79MGU1C, two of those. So 7.8 and 7.9 would say to me they're probably are voltage regulators. But, curious. Okay, let's get these ones out. These larger caps I'm going to try and push down to the board to make sure they're bedded down properly. It's not hanging off the leads. And then we're done. Just clean this board up, put it back in, and that's that unit finished. Good for another 30 years with a bit of luck. Some old flux on here from other people working on it. Guess it's been had some TLC over the years. We'll check these capacitors out soon. I don't know why I have trouble saying the word capacitor. When I'm doing a video I say capacitors or capacitor. I don't know. It's a capacitor. I don't know why I always end up pronouncing it wrong or weirdly. I don't know what it is. It's like I start saying it and think, oh, what's that word again? See this old Rosnian flux coming up there. A bit of tissue stuff to it. That wasn't me. Still a bit of residue on there, you can see in the camera. Your light's catching it. So I might give that a bit more of a clean with some fresh stuff. You don't have to see that, do you? Alright, let's check these capacitors out and see what we actually had in there. So this is a 2.4 millifarad. So that's slightly higher value than you expect. Dissipation looks good. ESR 0 ohms. It's just, that one's alright. ESR 0 ohms again looks okay. Those two look okay. I find largely, generally, the big caps in power supplies generally okay. It's the when you get to the switch mode stuff when they tend to be more problematic. 4.7 millifarad, that's right. 0 ohms. Dissipation on that one. 0.003. So these caps are actually really good still. There's that weird brand again. Whatever the hell that is. Cargan. Yeah. But it's only 85 degree rated though. But obviously it didn't matter because it's still good. Even after all this time. Next one. This is a 10 volt 1000 microfarad. 1000 microfarad, almost bang on. Dissipation looks good. 0.1 ohms ESR. Again, another good cap. What brand's this one? Yeah. Good question. There doesn't appear to be a brand on it. Anyway, it's 85 degree. But orange, I don't know. What's the significance of the orange? Anyone know? Put it down in the comments below. This is a 100 microfarad, 16 volt. You've got 3 of these. 90 microfarad, 91, slightly low, 1 ohm. Yeah, that's alright. .2, 1 ohm pretty much, 0.9, it's okay. 93, 1 ohm, so it looks like the power supply caps were at least looking alright. So any issues I saw initially were probably from those other boards. Just double check isn't it? I'm almost paranoid because one of these caps, I'll show you this. Sometimes you can get this, it's not uncommon. When you take a part out, you see that square shape on that part. If I can get it in focus, here you go. Think, oh crap, I pulled the pad off, but actually no, it's just solder, which hasn't fully melted. It's detached a little bit and retain the shape of the pad. So let's check it on here, and all the pads are still there. So, no, it hasn't ripped the pad off. See there's a square pad there, square pad here, and square pad there. All still there, so not a problem. Just supposed to double check, just in case something's screwed up. We can put it back in. Now, so I'm going to put some thermal compound on here. I'm just going to smear a little bit on the back, just to help it. I mean, it probably doesn't even need it, but I'm doing it, so, you know. At least then there's no doubt about whether or not it's got enough cooling. Don't like to leave things up to chance so I can avoid it. So let's just do this. It's going to be messy, but that's fine. I just want something there. It doesn't have to be good, it's because it's, I mean, it didn't have it there in the first place, so, you know, that'll be fine. It looks like crap, but it will do the job. So when I find out it's glue. Yes, that's right, it's fine. So I'll attach the rear screws first, then I'll do the PCB screws after that. I'll put the PCB screws in, but not tight, and then I'll attach the rear screws and tighten those up. That way it definitely lines up across all the screws. And plus, if they're in there, I'm less likely to drop something underneath it and get stuck. Because that happens. And it's always when you finish tightening up the last screw. Or it's the last screw you're putting in is the one which, you know, has that problem. It's like guaranteed. If something goes going to go wrong, that's going to be it. So yeah, the Boonton I've got, it's actually slightly nicer inside than this one. It looks, it's a later model or what, I'm not sure, but certainly more compact. But that's actually, the inside is like a work of art really. It's really nice. This isn't bad, you know, this looks like quite a good thing anyway, but so this is the problem. Last screw, it's going to be an awkward one. Right. Yeah, it's just really nice inside. It's quite impressive. It's nice when you find a piece of test kit. It's like, you know, someone's put a lot of effort into making it nice. You know, it's really well designed and it looks like it's been really thought out. Now to put the wires back on. Hopefully in the right places. So this one here is a bit of a weird one, where there's just one stray wire compared to everything else. I don't know why I've done that. So that pin there. Okay. So now we have, I might as well start from this end. So we've got 4. At least these are keyed. So as I say, Boonton did design stuff nicely like that. Well, did design stuff nicely. And this wire's all keyed so you can't plug them in back to front. So that's definitely 4, yep, so we want 10 next. Then we want nine. Something easy getting them off. 7, because 8 was missing, and 5. Okay, back together, plug the power back in. Right, let's do a smoke test. Ready? Get it shot. No bangs. Alright, is smoke working? Yes it is. So I think we're all good. I can put that shield back on here now, I don't have to worry about trying to access this area. Put this cover back on here. When I first got this thing, I pulled this shield off and I found this connector underneath it. So, I don't know whether that's from factory, they had it tucked away so it wouldn't wobble around or what, but I think I prefer to have it out like it's supposed to be. Are you ready for the time I drop the last screw? Are you watching for that? And it's going to go right inside the chassis, so I have to put it all apart. Anyone going to take any bets about when it's going to be? Might make it, we'll see. It's the last screw now. Oh no, sorry, be ripped off. Not this time. I have to say it's quite surprising. I was kind of expecting that to happen. Right, let's put the cover back on. Or covers back on. I did pull the other side back off again. I didn't show that in video, I don't think, because I made a mistake when I did one of those other boards. I put a capacitor in backwards. I'll take one of the boards back again. That's a bit dumb. Was it this board? No, that's right. I did probably right now. Remember, it was on that board there. I fixed that, and I found that this connector here, the one underneath, was coming apart. So I take all the connector out and recrimp it back together again. It's like coming apart. it seemed to be okay after that. So I was getting everything lining up on display instead of just what should have been lining up. So I had to take this whole ribbon cable out. Didn't miss much. It's not like I put a capacitor in backwards or anything. That just never happens. Something in my throat. See, one of these screw holes is stripped. Can't remember which one it was. One of them might be the top one. So you've got two different screws, so maybe one of the screws isn't even the right one, I don't know, but well, one's crosshead. I think. Actually, no, I had a screw missing. That's right. I put a crosshead in there because that's one I found which had the right thread. But one of these other screw holes was stripped. That's why the screw was missing. That's right. I think it was the top one. It's looking awfully wobbly. Yeah, it's kind of in. Right. Done. As AVE would say, time! Yeah, anyway. Yeah, that was quite a long time actually. That took a long time to do that refurbishment. Longer than I thought it was going to take. Okay, well, let's power it back up just to prove it still works after I put it back together. Let's plug a head in. I still need to read the manual on this thing, so I don't actually know how to calibrate it properly. How to set the probe calibration. Haven't done it yet. So, you know, I think I figured it out on the other unit. Let's have a little play with this. Get it screw in. See if we get it to work. This connector's also slightly bent. I'm not going to try straightening it. It could make it worse. Let's have a look. So, how the hell do you use this thing? I don't know. Cow? No. Power? I don't know what's going on here. I'm still thinking I've got an issue with something somewhere. There's lights lighting up here. Because when I had that capacitor backwards, all these LEDs came on. They were all on. That's gone away. But I'm still thinking I've got something wrong here somewhere because that has shown up again. Yeah. I'm not sure. I think maybe I've still got something else going on. I might have a loose connection somewhere. Might have to put it back apart. Anyway, that's enough of that refurb thing. We'll look at it another time maybe. Thanks for watching. Catch you later. Subscribe and all that usual stuff. Click the bell icon so you get notifications about videos and you know the drill. Share the video and maybe I'll see if I can fix this thing properly. Yeah. I'm going to be pulling this thing apart and checking out inside and recapping it because it needs a bit of a service. It's an RF MICROWATTMETER. I can't say it.